Welcome to my video. Today I'm going to talk about binary trees in Java and how to traverse them using something called a level order iterator. Uh, I will build a complete working example from scratch, and I will walk you through each line of the code so you fully understand what's happening and what will we will do today. Create a generic binary tree class and add a method to insert nodes level by level and implement a custom level order iterator class. And other than create a demo class to run the code, run the program and see the output. And finally we will discuss the time complexity of each part, and then let's get started. First of all, here has import Java util class iterator linked list, no such element exception, and the last one is q. And then let's get started. I start by defining our binary tree class. It's a generic class using t, which means we can store any type of data like string, integer, or even custom object. And inside the tree we have a private static class called node. Each node holds the actual data and a reference to its left child and a reference to its right child. This is the standard way to represent a binary tree node. And then let's continue with binary tree. This is the constructor. When we create a new tree, it starts empty, so the root is set to null. And then insert nodes level by level. This method lets us insert values into the tree using an array. The idea is to insert them in level order, so the tree is filled from top to bottom, left to right. And we start with the root node. Using the first element of the array, then we use a queue to keep track of nodes whose children we haven't added yet. And for every node in the queue, we add a child and a right child if available in the array. This makes it easy to build a complete binary tree. And then let's continue with let's continue. We create an inner class inside binary tree, the implements iterator t, and and the iterator uses a queue to manage which nodes to visit next. And in the constructor, if the tree is not empty, we enqueue the road. And next removes to the next node from the queue and adds its the left and right children to the queue if they exist, and then returns the data of the current node. So every time you call next, you get the next node in level order. And then here is the main method where we test our binary tree. And then first we create a tree that stores string, and then we insert values into it: A, B, C, D, E, F, and G. After that, we get the level order iterator, and finally we print out each value by looping throughout the iterator. And then let's running this code. Oh, expected value error. Oh, okay. And then let's running again. What's oh, sorry. Oops. And then let's running again. And then it's last one. When we run this code, the output will be level order traversal AB. Oops, sorry. A, B, C, D, E, F, and G, and process finished with exit code, and then code was finished. This confirmed that our iterator is working correctly. And then what will I explain? Oh, time complexities. Okay, let's go over the time complexity of each major part of our code. Insert level order is on. It's on because we process each element of the array once, inserting each node into the tree. And then get level order iterator is O1 because the constructor only adds the root node to the queue. And then level order iterator, this one. Then hex next O1 because just checked whether the queue is empty. And next is O1 amortized because each node is processed once and we add its children to the queue. And then okay, full traversal loop in main is O1 because we visit each of the n nodes exactly once. So overall everything is efficient and scales linearly with the number of nodes. And then alright, that's it for today's. And what we did today, built a flexible and generic binary tree class in Java, wrote a method to insert nodes using level order logic, and implement a custom level order iterator to traverse the tree, and run the program using a demo class and printed the traversal, this ones. And last one, reviewed the time complexities and why our solution is efficient. Okay, that's enough for today, and thanks for listening and watching. Have a good day. Bye bye.